On the Atlantic coast, outside the town of Zumaya, Dutch geologist Jan Smit was studying the forams from a different ancient sea. Their fossilized shells formed these limestone rocks, which, like Gubbio's mountains, were once at the bottom of the ocean.
20,000 years per.
Now exposed, they represent over 1 million years of a geological time period known as the Cretaceous. Like Alvarez in Italy, Smit had also found a strange clay layer formed at the same time, which told a dramatic story.
Jan, what can we tell about Earth's history from just looking at these rocks?
Well, you can see the end of the one world and the beginning of the next one. And you see there is a very sharp, extremely sharp dividing line between the two.
That gray band.
That's that gray band over there. At the bottom of that gray band, you see it's razor sharp.
And this reddish maroon rock, the oceans are healthy and steaming
They're
along just
healthy,
fine.
they're steady, they don't change at all. And all of a sudden we see a dramatic change, which we call the KT boundary.
The KT boundary, found at the bottom of this gray layer, marks not only the end of a period, the Cretaceous, but also of the Mesozoic era, a much longer stretch of time. The history of animal life on Earth has been divided into 3 such eras: early life, or Paleozoic, the age of dinosaurs, or Mesozoic, and the era of mammals, or Cenozoic. The Cretaceous Tertiary boundary lies right in between these 2 eras, marked here by this layer of clay.
What drew you to this boundary, Jan?
Well, Sean, we're looking here at the very topmost rocks of the Cretaceous. These rocks are literally packed with foraminifera. So we call this the Cretaceous, and these rocks here are the Tertiary. And the base of the Tertiary consists of a dark gray clay layer. And there the life has almost disappeared. And the KT boundary is just in between. I can point at it. It's right here where you see a contrast between the purple and the dark. It's an extremely sharp boundary.
And just across that thin little boundary, there's this huge change in what you see in the forams. And why is that so stunning to you?
It's so stunning because there is no preceding evidence of anything happening there. So it doesn't matter if I take a piece here, a piece there, or just underneath what we call the KT boundary. The foraminifera will remain the same, so they don't change overnight. And then, bang, they're gone.
So what's that tell you?
That tells me the base of the food chain of the oceans disappeared. And everything which is dependent on it is totally zapped right at the boundary.